So your focus question, how can you use a chip model to represent addition and subtraction? Before we go into the chip model, we are going to review the number line model that we ended with before Christmas break. Quickly. Jada?
I don't remember anything.
So, copy down these three problems. On my desk.
Oh my God.
I will remind you that we've already gone over the rule for adding integers. After we went over the rule, we looked at using a number line for adding integers to really show why the rule works. And then today we're using another strategy, which are integer chips. But instead of actually manipulating the chips, because you will not have chips available to you on the EOG, we will be drawing positive and negative chips. You will have your scratch paper and your pencil. So it will be another strategy, but understanding that the strategies are only for you to understand why the rule works and that you need to start using the rules. Because when you get to where these are fractions, these are decimals, these are much larger numbers, number lines and integer chips are not realistic for you to be using as a strategy on the EOG when you have those situations. So learning the rule and using the rule will work in all of those circumstances. So I will remind you of the rule. When the signs are the same, you add. When the signs were different, you subtracted. And that's what we did before we left for Christmas break. And again, when we go over these three and show you why the rule works using the number line, then we will move into using our integer chips. Yeah. Just put it over on the camera. Both of them are positive in number 1. They're both negative in number 2. They're different in number 3. So that's how the examples are different. We are going to make a number line for number 1. You need to make a number line. Using the number line model, you always start at 0. You have EOG questions tomorrow night for homework. There are 5 of these on the homework. So you will see a line that's at 0, and that's where you start. That first sign tells you which direction to move. Because it's positive, I'm moving to the right 6 times. So I start at 0 and I move to the right 1, 2, 3, 4, 5, 6. That's where I have stopped after my first move. And it says then I move to the right again 4 more times. 1, 2, 3, 4. I end up here at positive 10. That's why the answer here is positive 10. When the signs are the same, you're going in the same direction. That's why you add. And then you give that same sign to the answer. So had I not had the number line, and I saw that the signs were both positive, then I would know I had to add. 6 plus 4 was 10. They were both positive, so it's a positive 10. second one, they're the same again, except this time they're the same negative. So you're going to draw yourself a number line. I'm going to start at 0, so you will find your start line always at 0. The sign tells you what direction to move. The number tells you how many times to move in that direction. So it says move to the left 3 times from 0. So I'm going to move to the left 1, 2, 3 times, and it puts me right there at -3. Then it says move to the left again 2 more times. 1, 2. It puts me here at a -5, so my answer is a -5. So again, they're the same. So I add 3 plus 2 is 5. They're the same negative, so it's -5. So you're using the rules. So the reason the rule is that I add when they're the same is because when they're the same, I'm moving in the same direction. So I can add that amount on to the amount that I just moved because I'm going in the same direction. When we get to this one, it's different because they are not the same sign. This is a -6, this is a +4. So it's going to be different what I do. So we're doing a number line. Yes. I start at 0 always, and it says I move to the left 6 times. 1, 2, 3, 4, 5, 6. I'm right here at -6. It says then I move to the right 4 times. 1, 2, 3, 4, and I end up right here at a -2. So -2 is your answer. So the rule said if they're different, I subtract. They are different. 6 minus 4 is 2. The higher one is negative, so it's -2. The reason I subtract is because now I'm not going in the same direction. Now I'm backing up, and we already are familiar with what a 0 pair is. A +1 and a -1 cancels each other out. That's a 0 pair. Because on the number line, if I go to a +1 and I back up to a -1, I'm right back at 0. So it's a 0 pair. So what happens here is this negative and this positive cancels each other out. This negative and this positive cancels each other out. This negative and this positive cancels each other out. This negative and this positive cancels each other out. And I'm only left with this negative and this negative that I haven't canceled. So what's left on the number line was the answer. So that's why it worked, is because I was moving in a different direction and any of my overlaps cancel each other out. So that's what you're subtracting out, are all of those 0 pairs that happen when you switch direction. Logan. You're going to be looking at it as the integer test that we're going to be doing today. So what I'm going to do now is I'm going to take everything off the board and I'm going to write back the problems that we had. And then we're going to use a different model to get to this answer. Instead of the number line model, we're going to use the CHIP model. The CHIP model is what we're going to be using today to answer the problem that is in the book for 1.4.
I know you have a eraser over there, right?
Now, Poncho, quickly. We are going to do these 3 addition problems with the chips, but then I'm going to put 3 subtraction problems with the chips up here, because it is a little bit different what you do when you're subtracting with the chips. I will remind you what the rule for subtraction is before we do the subtraction problems. But you will be doing both addition and subtraction problems today using the CHIP model. So that's why I wanted you to see both before we actually went into the problem. We're going to use circles with pluses in them for positive chips, circles with negatives in them for negative chips. So if it says I start with 6 positive chips, then you're going to draw 6 positive chips. That's your first one. It says then I'm going to add 4 more positive chips. 1, 2, 3, 4. So once I do that, if I start with 6 positive chips and add 4 positive chips, then my answer is what I have left, 10 positive chips. So my answer is positive 10. So I can use the CHIP model, I can use the number line, or I can use the rule by simply knowing what I'm supposed to do if the signs are the same or if the signs are different. What this one says is I start with 3 negative chips, 1, 2, 3 negative chips, and then I add 2 more negative chips, and what do I end up with? 5 negative chips. Here I start with 6 negative chips. Now it wants me to add 4 positive chips. So I'm going to come down and I'm going to add 4 positive chips. When I added 4 positive chips, I created 4 zero pairs when I did that, because a positive and a negative cancels each other out. So this would go away, this would go away, this would, and this would, and all that I'm left with is 2 negative chips. No. So that's how you would use the CHIP model in addition. It is a little bit different when you have subtraction problems. So now I want you to write these 3 subtraction problems down.
Can I get a sheet of paper?
I got you. Never mind. You want us to do it with the chips too?
I'm going to show you how to do subtraction with the chips. Right now you're just copying these 3 problems down. And we're going to look at now how can you do subtraction with the chips. Now I will remind you that the rule for subtraction is keep the first number the same, change the sign from subtraction to addition, and then change the sign of the second number. So it's keep, change, change. And we will actually go through that process after we do the chip model to solve them. I will show you what you should be training your mind to do, because when you get into 8th grade, that's what she's going to be expecting you to do. So, if I start with 3 positive chips, 1, 2, 3. And I have to take away 2 positive chips. Do I have 2 positive chips?
Yeah.
Yes. I take them away, and so I end up with 1 positive chip. That's the answer, positive 1. Now, had I been doing the actual rule for this problem,
Yeah.
it would have been keep, change, change. That's what it should have looked like. And then, that's when you go back and follow these addition rules. Are the signs the same or different? They're different. So you subtract. 3 minus 2 is 1. The higher one is positive, so it's positive 1. So in subtraction, you should always be doing keep, change, change. Keep, change, change. Because when these numbers are fractions, decimals, or large numbers, that chip model is not realistic. You're not going to sit here and draw 125 negative chips when that's one of your problems. So it's best that you go ahead and you start checking yourself, even using the chip model in the lesson, that you're really knowing how to use the rule and that you're using that rule. So now when we're subtracting number 2, I start with 4 negative chips. 1, 2, 3, 4 negative chips. It tells me to remove 1 negative chip. Can I do that?
Yes.
Yes. So my answer is negative 3 chips.
But
That's what's left. Now, had I done this using the rule,
no.
and I'm supposed to keep, change, change, then I turn this into an addition problem. Are the signs the same or different?
Different.
Different. You subtract. 4 minus 1 is 3. The higher number is negative, so it's negative 3. So again, when these numbers get to be so much bigger, they get to be decimals or fractions, you're not going to be doing this strategy. But it is a good strategy to show you and explain why the rule works. Yes. You're going to use decimals and fractions with negatives this year, and it is on your 7th grade EOG. It is a 7th grade skill that whenever you now are learning how to add and subtract with positive and negative numbers, that those negatives are going to start being put on fractions and decimals this year. You will be tested on it this year. It will be on your homework tomorrow.
Wait, so this year, yeah.
So, if I'm now working on this one, where it tells me that I start with 5 negative chips, then you draw 5 negative chips. It tells me to remove 6 negative chips. Do I have 6 negative chips?
No.
No. So now what I have to do is I have to add a 0 pair. Now I have added this, but it's 0, so it hasn't changed the value of what I started with. Because this is a 0 I've added. A 0 pair. So now I can remove 6 negatives. 1, 2, 3, 4, 5, 6. And what have I got left? 1 positive chip. So that's the answer. So how did I get that if I'm following the rule?
Yeah.
then it's keep, change, change. Once I've done that, the signs are different. When they're different, I subtract. 6 minus 5 is 1. The higher one was positive, so it's positive 1. If you don't have that keep, change, change written somewhere, you need to write it and you need to memorize it. Because you're going to be subtracting and adding today in order to get through this problem. Quickly. Any questions about number 1, the review with how to use the number line that we did the week before we left? Or 2, how to use the integer chips with addition or subtraction? Skylar.
So what do you want to do when, you do keep change from the one to the end?
You do keep, change anytime you subtract. We're just using the chips and the number lines to show you why you do that. Because it's the same as adding the opposite. It is the additive inverse. When you subtract integers, it's really adding the opposite. And that adding the opposite is called the additive inverse, which is one of your words for this book that you've already got on your vocabulary chart and that you're responsible for defining, using, and knowing at the end when you take the vocabulary test. So it's adding the opposite, which is the additive inverse. That's what you do in all subtraction problems. No matter if these are fractions, no matter if these are decimals. If it's a subtraction, you keep, change, change. And then that's how you will proceed by changing them to these addition problems and then following these addition rules. Logan. No, because if you saw this, then you're going to get -1, and that's not the answer. So you have to keep, change, change so that you turn it into what it truly is. And if you don't use the integer chips, then you're visualizing that number line and knowing what you have to do in order to solve that problem. Why'd you shut the door? Turn in your textbooks to page 17 and let's go over the problem.